Welcome to Fascinating Frontiers, episode 106. Today is June 19th, 2026. Here's what's happening in space and science today. A Chinese university spacecraft will join international efforts to study asteroid Apophis during its unusually close 2029 pass by Earth. A spacecraft led by Tsinghua University will observe asteroid Apophis during its close Earth approach. The mission joins other international efforts already scheduled for the same encounter. Planners aim to gather data on the asteroid's shape, surface, and any changes induced by Earth's gravity. The university team is developing the probe independently while coordinating observation windows with other agencies. Launch timing will be set to ensure arrival well before the 2029 flyby. On a different note, data from NASA's Lucy spacecraft show evidence of chemical changes caused by liquid water on the asteroid Donald Johanson. Donald Johanson formed farther from the Sun before gravitational interactions moved it inward. The findings come from instruments that measured surface composition during the recent close pass. Researchers note the asteroid's interior may preserve records of early solar system water activity. Additional analysis of the full dataset is underway. Next up, observations of the cold exoplanet reveal clouds containing sodium and potassium salts. The planet ranks among the coldest worlds with a directly detected atmosphere. Webb's infrared instruments separated cloud composition from the background planetary signal. The salty clouds form at temperatures far below those where water clouds would condense. Further spectra will test whether similar chemistry appears on other cold giants. Shifting focus, the agency selected the Dynamic Atmosphere Ionosphere Explorer concept for Phase B development. Daphne will examine how space weather and lower atmosphere dynamics affect the near-Earth environment. Measurements should improve forecasts that protect GPS signals, low Earth orbit satellites, and astronauts. The mission will combine new instruments with existing ground networks. Scientists expect the data to clarify coupling processes between atmospheric layers. The European Space Agency deployed the E5a Quasi Pilot signal component across 12 Galileo satellites in April. This addition simplifies signal acquisition for mass market receivers that draw minimal power. The change targets Internet of Things sensors and smart city networks that previously struggled with standard navigation signals. Engineers designed the component to maintain compatibility with existing Galileo users while expanding reach to emerging applications. Next steps include monitoring performance on operational devices over the coming months. The Exploration rover for navigating extreme slope terrain completed field trials near Plaster City in March. Built at the Jet Propulsion Laboratory, the four-wheel vehicle carries advanced autonomy software intended for future lunar missions. The tests focused on higher speeds and greater total distance than current planetary rovers achieve. Data from the runs will refine navigation algorithms for steep terrain. Follow-on work will integrate the lessons into hardware for a potential lunar demonstration. The series returns to the waters off southern Florida, Cuba, and the Bahamas, featured in its first image from 2004. The new view highlights changes in coastal waters and land use over 2 decades. ESA's Earth observation team selected the region to demonstrate continuity in long-term monitoring. The image combines data from multiple satellites for consistent color and detail. Mu Technologies purchased a dedicated aircraft to begin offering parabolic flights to commercial clients. The new service is positioned to meet rising demand as NASA searches for replacement aircraft to support its microgravity experiments. Each flight will execute repeated parabolic arcs that generate short intervals of weightlessness for passengers and equipment. Researchers, along with private individuals, are expected to book flights for regular access to reduced gravity conditions. Full operations remain pending completion of required regulatory certification steps. Curiosity is now driving across distinct layered rock exposures on the slopes of Mount Sharp. The bands display clear differences in texture, color, and mineral content that each correspond to separate periods in Martian history. Mass cameras and contact science instruments are being used to document compositional changes from one layer to the next. The campaign seeks to tie these local outcrops to larger stratigraphic sequences already mapped from orbit. Results will help reconstruct how the ancient lake environment in Gale Crater changed over time. Fresh analysis of gamma-ray burst data indicates that long-duration events originate from the collapse of massive stars instead of neutron-star mergers. These bursts emit more total energy in a few seconds than the Sun generates across 10 billion years. Los Alamos researchers examined burst positions and the characteristics of their host galaxies to separate the two formation channels. The work overturns previous assumptions that assigned many long bursts to compact object mergers. Additional detections will be needed to confirm the revised classification scheme. Scientists have proposed using energetic neutral atom detectors to image the offset and tilted magnetosphere of Uranus. Voyager 2 provided the only direct measurements to date, leaving the ice giant's magnetic environment incompletely understood. Neutral atom imaging converts charged particles into detectable neutrals, allowing remote mapping without placing an orbiter at the planet. The same technique has already produced global views of Earth's and Saturn's magnetospheres. Mission concepts for a future Uranus probe are now considering inclusion of such an instrument. A recent study attributes gold concentrations in Western Australia to material delivered by an ancient meteorite impactor. The impact would have dispersed microscopic gold particles across a wide area upon arrival. Isotopic signatures in the ore deposits align with meteoritic sources rather than local crustal rock. This discovery adds another documented mechanism by which large impacts have enriched Earth's surface with valuable metals. Field teams are preparing sampling campaigns to identify the suspected crater location. Astronomers have associated a high-energy neutrino detection with a distant dusty star-forming galaxy nicknamed a shadow blaster. Confirmation would establish the first direct link between this class of galaxy and an observed neutrino. Intense star formation within the galaxy powers cosmic ray interactions capable of generating neutrinos. Follow-up observations are planned to search for additional events arriving from the same sky position. The association broadens the list of known neutrino sources beyond active galactic nuclei. Fermi observations point to two supernova remnants that originated from stars once bound in a binary system. The first explosion ejected its companion star, which later underwent its own core collapse, after traveling for thousands of years. Gamma-ray data show matching ages and spatial alignments consistent with this binary disruption sequence. The case supplies direct evidence that some core collapse supernovae occur within binary pairs. Additional remnant pairs will be examined for comparable signatures in future surveys. A 1976 dredge sample holds a few hundred atoms of plutonium isotopes, produced more than 100 million years ago. The material originated in a kilonova that followed the merger of two neutron stars. Debris from the event eventually reached Earth and settled into ferromanganese crust on the ocean floor. The isotopic ratios matched predictions for our process nucleosynthesis in mergers. Further measurements will refine the timing of the collision. If the Sun were the size of a basketball, a neutron star would be a marble packed with the same mass, roughly 1 billion tons per teaspoon. When two such marbles spiral together and collide, they release a brief but ferocious burst of neutrons that rapidly builds elements heavier than iron in a process called our process nucleosynthesis. Within seconds, the expanding cloud flings newly minted gold, platinum, and plutonium isotopes across thousands of light years. One particular merger more than 100 million years ago sent a fraction of that debris toward the forming solar system, where a few hundred plutonium atoms eventually settled into a Pacific Ocean ferromanganese crust. We can still detect those atoms today, yet we do not know how often such mergers occur in galaxies like the Milky Way, or exactly how much of Earth's heaviest elements arrive this way versus from other cosmic sources. Keep an eye on upcoming observations that could link more high-energy neutrinos to distant star-forming galaxies. That covers today's space and science news. Share this with a fellow space enthusiast if you found it interesting. I'm Patrick in Vancouver. See you tomorrow. And if you'd rather watch than listen, find us on YouTube at NARA Network. Links in the show notes. And before you go, this show is part of the NARA Network, a family of daily podcasts covering tech, science, markets, and more. If you enjoyed today's episode, give Modern Investing Techniques a listen. Modern strategies for Canadian and U.S. investors. You can explore the whole lineup at naranetwork.com. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
Drifting softly through